This video in the Resources on Proof series is about how to prove that something is a subgroup of a group. So let's look at a typical question where you might be asked to prove that something is a subgroup. So we have G, a group, which is the integers with addition. We have three subsets of Z, and we want to determine if those three subsets are subgroups. First thing to do when presented with any question is to recall the definition. So let's look at the definition. Let G with the combining rule be a group, let S be a subset of G. We say that S is a subgroup of G if and only if it satisfies the following two conditions. Condition 1, if you take any two elements of S and you combine them with the group rule, you end up with something that's still in S. And in condition 2, if you take any element of S, its inverse is also in S. Let's apply this to S1, the set of all even integers. I'm going to look at condition 1, which I'm going to prove using a direct proof because it's a fairly simple argument, it's a fairly simple situation. We take two arbitrary even elements, two arbitrary elements of S1, add them together, the result is still even, so still in S1, so S1 satisfies condition 1. Let's look at condition 2. If n is even, then its minus is even. So S1 satisfies condition 2, which since S1 satisfies both condition 1 and condition 2, it's a subgroup. Now let's look at S2. S2 is that every integer which is greater than or equal to number 1. So let's look at condition 1. If n1 and n2 are both arbitrary elements greater than 1, then so is their sum. So S2 satisfies condition 1. And let's look at condition 2. Now condition 2 in this case is false. So rather than an elaborate proof showing why S2 is false, I just need to provide a single counterexample. In this case, 2. 2 is greater than 1, but minus 2 is less than 1, so S2 fails condition 2. Since S2 doesn't satisfy both conditions, it's not a subgroup. Let's look at S3. S3 is quite complicated. It's every integer such that cos of pi times that integer divided by 2 is 0. Now, let's look at condition 1. Suppose if I'm not sure, just looking straight away at it, whether it's true or not, so I'm going to do some exploratory calculations. I'm going to take an arbitrary two elements of S3, assume that they're in elements of S3, and then look at their sum. Now, I take the cos of pi times n1 plus n2 all over 2, apply something I know, the multiple angle formula for cos, and we deduce something that gives us minus sine times something of something times sine of something. This looks like it's not going to be 0 when n1 and n2 are giving us causes of 0 because of the way the sine wave and the cos wave never sync up. So this means we can probably find a counterexample, and in this case, let n1 be 1, let n2 be 1. This gives us a counterexample. And since we have a counterexample, S3 does not satisfy condition 1. And since it doesn't satisfy condition 1, there's no point considering condition 2. For something to be a subgroup, it has to satisfy both conditions, and if we know it already fails 1, there's no point going any further. So we know that S3 is not a subgroup. Now this kind of proof technique will work for any subgroup in any group, but sometimes rather than going through all that work, you want to take a few shortcuts. So here are some results that you can use to prove that something is a subgroup indirectly rather than through this kind of calculation. Kernels and images of homomorphisms are always subgroups. Any subset which is generated by some x is automatically a subgroup. The intersection of two subgroups is always a subgroup. But be warned, that the same does not apply for unions. So the union of two subgroups is not necessarily a subgroup. Thank you for watching. There's a written resource available on this topic.